on the very center of our galaxy, and we can see if there's anything interesting there. And what we find when we zoom in on the very center of our galaxy is we find that there are some stars in the center of our galaxy. This cross is not real. This cross is not in the sky. This cross is placed at the precise center of our galaxy. We can determine where the precise center is. So we find these stars, and then what we can do is we can look at this part of the sky month after month, and we can make a movie. We can see if there's anything changing. And let me play that movie for you. Let me just say that I didn't do this work. This was brilliant work done by a group in Germany and a group in Los Angeles, University of California in Los Angeles. Let me play the movie for you. You find that the stars in the very center of our galaxy are moving. They're moving very fast. Let's just zoom in and watch this star. So the stars are moving very fast, and when we analyze the motions of the stars, we find that they are on orbits. We find that the stars are circling around something, and they are on orbits around something that's at the precise center of the galaxy. So if we wait a bit again, we see that this star here is on an elliptical orbit. It doesn't make that noise. It's on an elliptical orbit. Now, we can go back to our understanding of gravity, and we find that if there is a massive object here, it actually predicts that stars should be on elliptical orbits around that point. It's just like the solar system. In the solar system, the planets are not quite on circular orbits, they're on elliptical orbits. For example, Pluto is actually on a very elliptical orbit. So these stars are orbiting around something which is located at the precise center of the galaxy. They're also moving very fast. So when this star does that, when it gets very close, it is moving at 7,000 kilometers per second. So this is a whole star. This is a big thing, and it is being accelerated to 7,000 kilometers per second. So whatever it is orbiting around must have very strong gravity, must have a very strong gravitational pull to be able to take an entire star and speed it up to 7,000 kilometers per second. Now, I focused on the most obvious star is the one which I pointed out. But in fact, you can analyze the orbits of all of the other stars, and you find that they are on paths which are being curved by the central orbit. So every star here is on an orbit around that central point. So there must be a very massive object here that's accelerating these stars. But there is something very important to note about this point in the image. I'm actually going to take the cross away. What's the important thing that we should notice? What is the important thing about this point here?
如果没有那个箭头的话，大家对那个地方有什么印象？ Nothing.
Yes, exactly. There is nothing there. It is dark. It's completely dark. So there must be a very massive object there that's completely dark. Now we can analyze the orbits, and we find that we need 4 million solar masses, 4 million times the mass of the sun, to be located here. And it is completely dark. So we cannot say that there is a 4 million solar mass star there, because that would be bright. So whatever is there must be very dark.
这个很重要的，这张图大概是这次演讲的第一张，就是我们应该印象很深刻，因为这也是一个很先进的研究啊，不是袁总教授，但是他把银河中心附近的星球运动的状态仔细的把它画出来。可是在我们对于轨道知道很多，就我们知道在那个 cross 画那个十字线的地方啊，应该是它的中心点，可是中心点什么都没有。 可是那边一定要有400万个太阳质量的东西在那边，才可以让周围的东西这样子运动啊，动这么快啊。400万个太阳的东西，可是没有400万个恒星在那边嘛，没有发光，什么都没有，黑很黑的。
So we can ask the question. What are all the possible objects that could be here, which are so massive and so dark? And in fact, the only possibility, the only option, is that this is a black hole. Any other object we could think of to put here, suppose we had 4 million solar masses of rock, for example, we would still see that. We would see infrared emission from it. There is no other option from the black hole. So we believe that at the center of our galaxy, there is a black hole. It has a mass of 3 to 4 million solar masses. It has a radius in this range. It's radius between about 4 to 12 million solar masses. The uncertainty, we don't know the radius because the size of the black hole actually depends upon how quickly the black hole is rotating. If the black hole rotates, then that can affect its size. So that's why there is a range on its size. The little yellow dot here is the size of the sun compared to this black hole. So you can see that the sun, that this black hole is enormous compared to the size of the sun. I think this was assuming the larger radius. So this is extremely strong evidence for the existence of a black hole at the center of our galaxy. Physicists, people who are trying to understand gravity, the main thing they're interested in is, do black holes exist? And this observation I've shown you is extremely strong evidence for black holes existing.
对就这是一个很强的证据啊，就是人问说黑洞存不存在的啊？黑洞理论上一定要存在，因为东西很多在大，那这是一个很好的一个证据，就是在我们银河系中心。 别的星系的中心都有这种超大的质量黑洞，在我们银河系中心的这个黑洞它的质量大概是300万到400万个太阳质量。所以那刚才你讲那个黄色的那个小点，大概就是太阳的大小。这一个黑洞本身就比太阳要大非常多。好了，那我们主任现在是下课10分钟，是吧？好，下课10分钟。